Hi. Um, so today we're going to find a solution of inequalities between two graphs, a parabola and a straight line. So we're going to shade an area, and that area that's shaded, all the numbers in that shaded region, when you apply them to both equations, they'll give you a true statement. So basically, you're looking for that area that satisfies both equations. So when you graphing this, the first thing you need to do is ignore the inequality sign for now, and just basically trying to graph y equals negative brackets x plus 2 squared plus 4. And so when we're graphing this kind of parabola, we look for the vertex. And for any of you who forgot the equation for a parabola, it's y equals ax minus p squared plus q, where the vertex is p and q. The axis of symmetry, because every parabola has an axis of symmetry. Is x equals p, so the x value of the vertex. A is basically, it controls where the parabola opens, if it opens up or down. So if it's positive, the parabola should be opening up. If negative, the parabola should be opening down. Also, expansion and compression of the parabola, is the parabola expanded, usually vertically. So if it's expanded vertically, it will shrink horizontally. And if it shrinks vertically, then it expands horizontally, kind of thing. So if I'm looking at the vertex here, it is -2 and 4. Always change the sign of that, because here it's minus p, so I put p. So change the sign of the p value. So if it's x plus 2, then it's -2. So I'm going to go ahead and plot that -2 and 4. Okay, there are many ways to plot a parabola. There's, if you want to memorize, go out 1, and since it's negative, you go out 1, down 1, out 1, down 3. But what I find useful is table of values. And why? Because every graph you could reflect on table of values, and you'll be able to see somehow how the graph looks like. The more complicated the graph, the more knowledge you have to have about what kind of graph it is. Is the domain, does the domain have any restrictions, and all of that. And then you still could apply table of values after that. Table of values is when you're doing a parabola, it's I advise you just to do basically 2 points. Okay, of course you're going to write the -2 and 4, which a point you already have, the vertex, and now choose the x value that are next to -2. So you get your numbers within range, where you don't get a y value that's 36 or something like that, where you cannot fit it in here. So, but anyway, so the next number I'm going to go to here is either -3 and -4, or -1 and 0. So I'm just going to go -1. That's the next number, and then after -1, there's the 0. So if I sub in -1 here, and you just have to do your arithmetics, eh? So basically, you put in -1 here, you're doing your calculations. Remember, BEDMAS. So if I put in -1 here, -1 plus 2 is 1. 1 squared is 1. Then you have a negative in front of that one, so that makes it -1. -1 plus 4 is 3. And then if you plug in 0, 0 plus 2 is 2. 2 squared is 4. The negative, it doesn't matter. Sorry. So it's -4. If it's 0, it's the negative, doesn't matter. I'm going ahead of myself. So 2 plus 2 is 0 plus 2 is 2. 2 squared is 4. A negative in front of the 4 makes it -4 plus 4 is 0. So you got a point that's 0 and 0. Now I know my axis of symmetry is the dotted line right through the in here. So through the vertex, you know, which is -2 and 4. Now if I plot in -1 and 3, so -1 and 3 are right there, and negative and 0 and 0. Now take this point, reflect it into the axis of symmetry. So it's one away from the axis of symmetry. So you go one away on the other side and you have your other point. And this is 2 away. And then you go 2 on this side, 2 away on the other side, and you get your other point. Now, basically, besides the vertex, you have 4 points, you know. Usually they say at least, graph at least 2 points, show at least 2 points. But here, once you do these two, you could reflect them and show 4 points on your graph. And I'm just going to go ahead and plot that. So and there's your parabola. Okay. Now you have the line that's y, and here I'm just gonna maybe use a different color. Instead of y is less than x, you just go for y equals x. That's a diagonal line right through here, because when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. So y equals x is a line that is just whatever the x, y, whatever the input is, the input will equal, the output will be the same. And then you just graph your straight line through here. So I'm just gonna go, so right there. So now I have my straight line and I have my parabola that's opening down. You remember from the last lesson, I said always better to test 0, 0 because it's easier point to work with. Here we can't. And the reason why we can't, because your graphs are going through 0. Both of them, they go through 0, 0. So you don't want to be testing a point that's right on the graph. You always want to test a point either above, let's say that if I'm testing the line, it's either above or below. Make sure your numbers are small, you know, either one, and positive if you can, because lots of students don't like working with negative numbers. So what I'm going to do for the red, okay, for if I'm testing, okay, let's start with the parabola. So I'm testing for the parabola, the inequality for the parabola here. So what I'm going to use for the parabola, I'm going to use something inside the parabola. Okay, let's choose something outside of the parabola. So let's choose 0, 1, because inside the parabola, the numbers will be negative. So I'm going to choose 0, 1. So testing 0, 1 in the parabola. So then we just sub in 0 and 1. So that's the x, this is the y value. So 1 is less than or equal to negative 0 for x plus 2 squared plus 4. Now, if we do that, we got 0 plus 2, that's 2. 2 squared is 4. That's negative 4 plus 4 is 0. So we got 1 is less than or equal to 0. Is that true? No, that's false. Those 0, 1 happens to be outside of the parabola. So since it's false, I don't shade outside of the parabola. I have to shade inside the parabola right there. So just inside the parabola. Okay. And then I'm going to go test the line as well. So I'm just going to use red for the line. So you see that's a different graph. Less than x. And did anybody notice a mistake that I made? The mistake I made is, or it's y is less than x. This has to be a dotted line. So I'm just gonna. So if there's no equal sign with the inequality sign, it's not a straight line. It has to be a dotted line. So just make sure you remember that. So bear with me. I'm just I'm gonna try to make a nice dotted line. Okay. There we go. So I'm gonna go ahead and test, and you know what? 0 and 1, which is here, it's above the line. So I'm gonna test 0 and 1 again. You could test any point, it doesn't matter. 0 and 1, easier numbers to work with. So 1 is y and x is 0. So I got 1 is less than 0, definitely false. 0 and 1 is above the line, you know, if you look at it like above. Therefore, I cannot shade where 0 and 1 is. I have to shade under the line. So what I'm saying is, since 0 and 1 is above the line, and when I tested it, it's not true. If it's true, I'll shade where that point is. But since it's false, then I shade on the other side, which is, you know, not above, but below the line. And below the line would be all this area right here. Now, see where your shading overlaps. This is the area that must be shaded, and everything else has to be erased. So that's your shading region right here. Yeah. I'm just gonna erase some of the shading that doesn't work. And here, whoops. Did I? So there we go. There's your shading right there. Again, what does that mean? I think a lot of students, when they do the shading and all of that stuff, they don't understand what that means. It means all the points in here, when you plug them into there and there, they'll give you a true statement. Let's try it. Let's choose a point that's in this region right here. Make sure your numbers are small, because the bigger you make them, the more calculations that you might have to use the calculator. So can anybody see a point that's in this here that's easy? If it has a 0 in it, it's always good, you know? So you know what? See 0 and -1 right here? 0 and -1. If I sub it into the first equation, I'll get -1 is less than or equal to -0 plus 2 squared plus 4. And then this is 4 negative. So I get -1 is less than or equal to 0. And that's true. So as I'm saying, any point that doesn't need to be 0 and -1, it could be 0 and -2. It could be -2 and -8, for instance. All of these points will satisfy that. And also, if you plug them into the other equation, which is this, so y is -1 is less than, and the x is 0, and that's true as well. So as I said earlier, like what you're trying to find is all the points or shade where all the points that satisfy both equations. Okay, so we're done with this. We're gonna take another example where we're gonna graph a parabola and a line again. This parabola is not in vertex form, it's in factored form. So the next question is x minus 4y is less than or equal to 4. And the other one is y is less than or equal to -1/2 x minus 2 x plus 3. So let me just make this x a little bit better. I don't know if that's better, but it's an x. So the next thing is, the first thing I'm gonna graph is the straight line, you know. This one here, you could change it to y equals mx plus b and do it that way. But you know what? I'm just gonna use, so I'm gonna graph again, x minus 4y equals 4. And most all this inequality sign have equal signs, so all of them are solid line. There's no dotting or dotted lines or dotted curve in the parabola or anything like that. So this one here, if you don't want to change it to slope y-intercept form, what I do usually is just I find the x-intercept. Oops, the x-intercept, yeah, and the y-intercept. Because these numbers they go into one another. With the 4, it's very easy to find your x-intercept and the y-intercept. Sorry, x-intercept, y-intercept. The x-intercept here, which means where you intersect the x-axis, just get rid of the 4y. Get rid of this. You'll end up with x equaling 4. So that's your x-intercept. The y-intercept, get rid of the x. If you get rid of the x, you have negative 4y equals 4. And therefore, y equals negative 1 when you divide both sides by negative 4. So now you have your x-intercept, your y-intercept. X-intercept is 4. Y-intercept is negative 1. Just from these 2 points, you could tell what your slope is for the line, eh? Because see, you're going up 1 and then to the right 1, 2, 3, 4. If you want more points, just keep on doing that. Up 1, 1, 2, 3, 4. And if you go down 1, don't go right 4, because if you're going to go right 4, you're not going to get a straight line. But if you go down 1 and left 4, and then go down 1 and left 4, it doesn't matter how many points you want to have on this line. You could have as many as you want. You know, I notice through my experience doing this kind of work, you know, since 1996, some students, they don't use logic. So, you know, let's say if you have 2 points and I say do more points, is the slope negative? Is the slope positive? And then should I go down 1 or go up 1? Do the same thing that's happening here. If you're going up 1 over 4, then you go up 1 over 4 again to get your other point, and that looks good because it's the same kind of trend, you know. But here, if you say, oh, do I go down 1 and over 4? Well, if you do that, you're going to get the V facing this way, and that's supposed to be a straight line. So you definitely do 1 over 4. And definitely you don't go up 1 and left 4, because then you get the V going this way. A wide V, of course. So this always use logic, you know, math. You have to use some of the logic while you're doing things, you know, and that, you know, and it's good to try and get it wrong. You know, I think a lot of students in math, they think that the answer is just going to pop up, you know, like after they ask you a question in biology or something. No, in math, it's try and error. That's how you learn, you know. You have tools, apply them, and you'll find out, you know, and you have to do that all the time. It's not, oh, they give you the question and the answer pops up. No, it doesn't. In math, you really have to use the tools that you have to try to get to the answer, you know. Everybody gets a question every now and then that they stump on, and then you just have to use all tools. The more tools you have, the easier it is to solve the question. So let me graph this straight line. It's a solid line that I have. And this app here, I have like a nice straight line that I could make. So there you go. Oops. So this is your straight line right there. And then I'm going to change to blue. So, you know, I'm doing the parabola. And this parabola here, see, I'm graphing y equals -½ x minus 2, x plus 3. We go back to the inequalities once we start testing and to find out where we shade, but you're simply just graphing a parabola. So in this format, right away, you know your x-intercept. So graphing the parabola, my zeros are x equals 2 and -3. So right, -3 is right here, and 2 is right there. My vertex is going to be right in the middle. So 1, 2, 3, 4, 5. That's the distance between the two zeros. Now, my vertex is going to be right in the middle. So at -0.5. You could just add -3 plus 2 and then divide them by 2 to find the average. So my vertex, which is my axis of symmetry, should be more at -0.5. So to find the vertex, you know that the x value is going to be the x value is going to be at -0.5 or -0.5. We need to find out what the y value is for the vertex. So this is P, and then we need to find out what Q is. So to find out what Q is, just sub in the -0.5 in the axis right here. So y equals -1/2, -1/2 minus 2, and -1/2 plus 3. And that's basically is going to give us -1/2. -1/2 minus 2, just -2.5. I'm just going to go to decimals here to make this easier. And -1/2 plus 3 is 2.5. So I'm just going to calculate what that gives me. So sorry, that's a -2.5 right here. I just missed the negative. So what we have the answer is going to be positive, but -1/2, so it's going to be positive because negative times negative is going to be positive. So just 0.5 times 2.5 times 2.5 again equals 3.125. So my vertex is at 3.125, so about 3.1. So it's going to be right here. And then you're just going to graph this parabola right there. Oops. Okay. Now we come to the part where we're going to be testing where we're going to shade. So for the 0, 0 actually works right now because none of these graphs go through 0, 0, and 0, 0 is always the best one to work with. So I'm going to test for the parabola since I'm on blue right now. So y is less than or equal -1/2. And we said we're going to test 0, 0. Test 0, 0. So now if we plug in 0 for x, we're just going to get -2. And if we sub in 0 for x here, we're just going to get 0 plus 3, which is 3. So, and we sub in, 0 for the y as well. Yeah. So now we get 0 is less than or equal. If you look at this, this is basically -1/2 times -2 is +1 times 3 is 3. Is this true? No, it's not. Oh, sorry. Yes, it is. So it's true. Yes, it is. If it's true, you shade where 0 and 0 is. 0 and 0 is inside the parabola. So you shade where 0 and 0 is. Now, we're going to go and test 0, 0 again for the line. So we sub in 0 for x minus 4 times 0 is less than or equal to 4. That gives me 0 here, 4. So I get 0 is less than or equal to 4. That's true as well. So, and 0, 0 happens to be above the line. That's what I meant. So it's above the line. So you just shade all above the line. Yeah. And so now you look for where your shading overlaps. So it overlaps right in this portion right here. And this is the only area that you're going to shade because it has to satisfy both of them. And that's the only region that satisfies both equations or both inequalities. So that's where you're shading. and everything else you have to get rid of. So you gotta get rid of this stuff, dang, 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 and then also this, and this is your shading region. This is it, solving inequalities. We did them with 2 lines. Now we did them with parabolas. They are pretty straightforward if you know what you're doing and following a certain procedure. Again, math is like a puzzle, and it's always fun to solve a puzzle. I'll talk to you later. Stay safe. Till next time. Bye-bye.